Let's see a probability density function in action. Here's the setup. We have a machine and it's filling bottles of milk. On the bottle of milk, it says that this bottle has 500 milliliters. The machine does a pretty good job. It does its best, but it has some error, and that error is random. And it's governed by this probability density function that we've already been talking about. So we saw that this probability density function was symmetric about the y-axis. It has even symmetry. So the machine is equally likely to dispense 1 milliliter too much as it is to dispense 1 milliliter too little. But those things aren't the same to the consumer. If the bottle says it has 500 milliliters, it's okay if it has 501. It's not okay if it has 499. So what we're going to do is we're not actually going to tell the machine to dispense exactly 500 milliliters. We're going to tell it to dispense a little bit more. 500 milliliters plus a little bit extra. So if we tell the machine to dispense 501 milliliters and it's a milliliter short, that's actually okay. But if it's 2 milliliters short, that's not okay. So the problem arises if I tell it to give an extra A and it is short by more than A. So this probability, the probability that my error is less than negative extra amount, this is the problem probability. And this is what I want to have happen less than 1% in the time. So I want this probability to be less than 1 out of 100. If this is less than 1 out of 100, then less than 1% of the time, my machine has an error that causes the total weight of my bottle to be less than the 500 milliliters that is advertised. Once we have this set up, using what we know about the probability density function, we can find the value of A that will make this work. I need to find the value of A such that the probability of my error being less than or equal to negative A is no more than 1 in 100. The probability that X is less than or equal to negative A, well, that's exactly big F of negative A, my cumulative distribution function of negative A. And we've also figured out our cumulative distribution function. So if we recall from the last video, the cumulative distribution function for this probability density function was 1/2 e to the x when x was negative, and 1/2 minus 1/2 e to the negative x when x was positive. Negative A, well, we chose A to be positive, that's our extra, so negative A is negative, so this is simply 1/2 e to the negative A. This is the probability that I have an error that causes my machine to fill the bottle so lightly that even with my extra A, the total bottle comes out too light. So this is what I want to be less than or equal to 1%. Now I just have to solve for A. So I can multiply, let's see, this is 1 over 2 times e to the A, should be less than 1 over 100. I can take the reciprocal of both sides of this. Remember, that means I have to flip the inequality. E to the A needs to be at least 50, so A should be at least the natural log of 50. So as long as I put in at least log 50 extra when I calibrate the machine, I ask the machine to dispense 500 plus log 50 milliliters, then less than 1% of the time will the error in the dispensing be so great that my final bottle weight will be less than the advertised 500 milliliters.